that looking right? Sorry, I'm doing this on one screen. I normally have about 3 or 4, so it's a little bit awkward, but we'll get through it. Yeah, you guys are seeing everything. Okay, cool. So my name is Marc LeBlanc. I'm a delivery leader over here at Arctic here in Toronto. Spent a few years playing around with the HashiStack and some of our cloud journeys that we work on quite a bit. So what I'm talking about today is just around the idea of legacy services on service meshes. So what is that exactly? So I kind of threw some terms up here that come to mind when I think about what it is, where this idea came from. So we're talking about service meshes, we're talking about microservices, we're talking about Kubernetes. And what do they all have to, why does it matter? Why does it matter? The question kind of came up, we were thinking about a while back. Everyone today is talking about microservices, service meshes, really rapidly changing infrastructure. And the big question was like, what about all the other stuff that's not there yet? So that's where this talk kind of came from. That's the premise. We're gonna do a bit better explaining the story here. So what we're seeing in the industry, what we're kind of encountering is there's a huge push to go from these monolithic, these static applications over to a more highly dynamic configuration. We're seeing them span different cloud providers. We're seeing them span across to private clouds and different platforms. People are going serverless. They're kind of all over the place. And where they're coming from, if we think about where we're coming from and why service meshes have kind of come to be, if we look at the traditional approach to networking, we had a highly static footprint. It was scaled, it was built for a certain size. We would put a large networking infrastructure. It would be there, it'd be static, it wouldn't change very much. It would be very ticket-driven change processes. So if you needed to make a change to upgrade a device BIOS or whatever, you would have to put a ticket in, you go through a change process, take a long time. And there's very complicated firewall rule sprawl. So that's kind of where people are coming from. That's the static monolithic applications that we've seen for the last little bit. Where we're going, if we think about, let's talk about Kubernetes use case for a moment. Everything is dynamic, everything is ephemeral. So we have these services that are coming up, they're living for short periods of time, they disappear, they come back online with a different IP address, maybe in a different availability zone. The network perimeters are a lot less clear, and we're seeing a lot more predominantly east-west traffic across this infrastructure. And so to answer that, service meshes started becoming a big topic. I think when I first asked someone about Consul, it was described to me, this was a few years back, well, Consul is a backend for Vault. It's a key value store. That was kind of my first introduction to Vault. And probably, I think it was mid-2018, about Consul 1.2, I think, a component of Consul called Connect was released. And that brought service mesh capability to Consul. So why are we looking at service meshes? Why was Connect so interesting? Well, we're bringing service discovery. We're getting more rapid ways for our platforms to discover these services as they come online. We're getting increased observability. We're getting really fine-grained access control through ACLs. There's things like intentions in Consul that I'll show you in the UI. And we have secure service-to-service communication and traffic governance. All really neat things, but I'm not going to focus on all these today. Today is really about that legacy service and why does it matter. So these are the things that service meshes are bringing to the table. But the important thing is that it's happening at the platform level. So we're taking the complexity of making sure that things are baked into the application layer. We're pushing that down to the platform level and making sure that it's just there by default. So that's an important part of this message, that once a service is on a service mesh, it has these features available just by default. So one of the patterns we see with service mesh, and especially with Consul, is putting them on Kubernetes. I don't know that we've worked a project in the last 2 years where service mesh isn't part of the discussion. Maybe it's not part of the ask, but it's definitely part of the conversation. When people are moving microservices, they have to have that answer. How are you going to serve that traffic out, or serve that access out, and make sure that it's secure and make sure that it's getting where it needs to be. So Consul on Kubernetes is really nice. It's one of the nicest things to work with. It's super easy. You can install it with Helm. There's a really nice official Helm chart for it. You can set up the auto sidecar injection. And it really fits that dynamic services model for discovery. It does it really well. I know there's a bunch of stats published around how quickly Consul can get these things advertised. I don't know them off the top of my head, but they're very well documented and out there on the interwebs. So what it looks like when we deploy this in Kubernetes, you have service, it has a sidecar proxy, it's got secure communication via MTLS over to a neighboring service that you're trying to connect to through the sidecar, and that connects to service B. Service A talks to service B, straight line, makes sense. Starting in Consul 1.6, and this was about probably mid-2019, I think, Consul added another feature called Mesh Gateways. And this gave us the ability to spread that service mesh across data centers. And I did grab an architecture diagram off of the Consul site, and I'll just go over some of the points really quickly because it's kind of interesting. So at the top here, we can see that we're defining the mesh gateway to be federated across the two data centers, that dashed blue line. But what's really interesting is the data plane that's represented by these three colors at the bottom, the yellow, orange, and the blue. And probably the most important line to take a peek at is this blue one that is showing the point-to-point communication. That's one of the main things that I think is really interesting with service meshes, is the point-to-point communication that's secured by MTLS that we get when we start enabling this type of service. So if you sort of think back to what I was saying a couple of slides ago, I was talking about how easy it is to work with Consul and Kubernetes. It's a dream, how easy it was to just kind of get running with it. This is what it kind of looks like. This is a pattern I think that people assume we'll be going with. Put a Consul cluster on one Kubernetes cluster, put it on another, enable the gateway, away you go. We have a federated Consul mesh across two clusters. It makes sense. You're going to have these highly dynamic services in both clusters that can do service discovery really quick. We can secure it. We can do all kinds of neat things with service meshes. But the reality of what is out there is we're left with a blend. People aren't automatically saying, yes, I want microservices, and then tomorrow they have microservices. They have all the answers. No, what we're really seeing is we have some legacy services, some monolithic application or service that's sticking around, as well as those microservices, those newer services that they've deployed. I'm sure if this was a live audience and I polled and said, does this sound like something you're faced with? There'd be a lot of heads nodding. So if we step back and take a look at what's that high-level architecture of the federated service mesh, this is what it kind of looks like. And if we kind of forget about the fact that it could be Kubernetes on the left or the right, or VMs on the left or the right, or serverless, this is the architecture. It does not matter. Because Consul has the ability to be injected into containers, we can run it on VMs. This is what it looks like. So if we had on our right-hand side here, if we had VMs, we can install our Consul cluster there, we can enable the mesh gateway, and we connect that up to GCP, which could be running a Kubernetes cluster or VMs or whatever it is you have. So that's kind of the points I wanted to get across, but I wanted to take a look because I wanted to showcase a couple of quick things. One of the things I wanted to show was, again, how easy it is to get services on a service mesh in Kubernetes, because I think that's really cool. And then what I want to do is just show some of the communication that can happen across that federated link. So let me get back to this platform so I can switch the screen I'm sharing. And it should be This one. All right. Now that it's shared, I have to actually find it. Here we are. All right. So here's my repo that I used when I was sort of setting this up. Now, take a look in I have a Kubernetes cluster running that I've deployed console on already. So I just wanted to show a quick look at what that looks like. Various things in various states. I also have a number of VMs that are running. So let me just explain what I just showed here. On the top, these are the pods running in my Kubernetes cluster. This is the console cluster running on a GKE node cluster. These 5 servers down here, console 0, 1, 2, 3, 4. This is the console cluster running on VMs and GCP. These are VM-based install. If I pop over to the UI, what I think is neat anyway is from a single spot I can see my entire environment. So I've logged into console 0 on the port that it's running on, and I can see both sets of environments. So one of the best practices for console is when you're setting up a data center is that it should not go beyond the physical boundaries of that data center. So what I've done is I've kind of made the assumption in this world that this setup, my VMs are one data center, my Kubernetes cluster is the other. So I switched to the DC1, which is my VM-based install. I can see my nodes. If I switch back over to the GKE install, we can see the different pods that are running to get the different nodes and the server that's running. Now, we have no services running here other than console itself and the mesh gateway. What I want to do is we're going to put 2 services on there. And this is a demo app off of the console site on one of their repos. We have one that's showing a little bit of dependency between accounting app and a dashboard app. What those look like. So if you've worked with Kubernetes, we've all seen these YAML deployment files. So we have a service that we're going to deploy. It's called accounting. It's going to run in port 9001. And then the really neat thing that makes this happen so seamlessly is just this really simple annotation to do the connect inject. Set it to true. The dashboard one, the one added thing is we're defining an upstream. So there's a dependency on that counting application for this one called dashboard. So this is the dashboard YAML. This is the counting YAML. So let's go ahead and deploy these. Watch for those to start. So one's ready. So if I pop over to the UI, we can see that the counting app, the counting service is now available. And the dashboard one's running there now. So I pop over here to refresh. Okay. So I'm not sure why the dashboard one is not showing up like it did an hour ago, but that's okay. Because what I want to show, now that we have this online, I want to pop onto one of the VMs. So remember that this is the Kubernetes-based data center. We don't see it running in the VM-based one. So what I'll do is we'll just pull this up. SSH into that node. So what I want to show, if we ping that service, so the service name is client.service, and then you name your data center. I get nothing. But if we query this from console, we can see that we get an answer back. And what's interesting about this come over to our Kubernetes cluster. I'm trying to make this so you can see it. I hope this isn't too small. I should have increased the font size. But I see the pod running here. I see the IP here. And that's what it replied with. So think about for a moment how pods can come up and down, and those IPs are ephemeral. So if this was a service that was scaling very rapidly, how would it know what IP to get? That's where console becomes really powerful, because it can do that discovery very, very quickly and make sure that the traffic's getting where it needs to be. So just to replay back what I just showed, from the VM on the left-hand side, we queried another data center, which was running on Kubernetes, through console, and we found the service. Really cool. Close that one down. The last thing I'm going to show you is we're going to do something similar with a VM. I'm just going to show what it looks like to get a service online. We get the IP of that server. I've got a server ready to go here. This one called Demo App. I know it's wrong. Because I'm running a browser version of VS Code, my copy and paste command is closing things instead of copying. So sorry about that. Is this one? That is not the right name. For dot. There we go. That's better. So the process to get, so this is a server, no console installed, no app installed. What it's going to do, quickly throw the console binary on there. And then I have configuration. So I have two configurations. I have one that defines the client. So the base, this is how the console agent running on this VM, this is how it knows about the cluster and how to get on. And then I have a service defined in this one called front end. So let's take a look at that one for a moment. This is a pretty minimal config. So I'm naming a service called front end. I'm telling it it's on port 80. Now, in reality, you would want to have some checks, some health checks to make sure the service is actually running. Not going to bother with that for this demo. We're going to move these two files over to the console directory. membership. I can see that it's there. I can see that it's joined. So I didn't show this yet. So console members, I see all the nodes in this data center. So console 0, 1, 2, 3, 4. They are all of type server. And then notice this last one that's joined now, it's type client. And if I pop over to the UI, just do a refresh, we can see that our service is there. So that's how quick and easy. We just did that kind of live. It took, I don't know, 2 minutes, other than the SSH difficulties. So if we think about what this might look like, think about that dashboard service that's running over in Kubernetes. That's not showing up. We could have a dependency from that front-end app that's running on VM over to one of these apps back here in Kubernetes. That's where the power of the service mesh and why it matters for legacy services. That's where it kind of comes together. So if you had a service that's running on-prem that's been around for 20 years or something, that it's complex, it's hard to move. Yes, you want to move it to microservices, but it's not going away anytime soon. This is how we can bring everything together to talk on that consistent connection, secured. We have the ACLs, we have things like intentions, we can do token-based access. That's why it matters. Now, if I switch back to, for anyone else presenting, don't do it with one screen. This is a pain in the butt. So that's kind of the talk. If I think about some of the other things going on with service meshes and some of the announcements around console, specifically, I think it was already mentioned today at HashiCorp, it was announced about the console API gateway. If we think about how we can federate our data centers, our on-prem, our legacy services, new microservices as they come online, and you slap something like an API gateway in front of that, that's really powerful when we can intelligently route our API requests to those backends over something like a service mesh in an API gateway. So that's where things are going. I think it's really interesting.
Awesome. Thank you so much for joining us today. Sorry, I was like, where's my mute button? Oh, no. But thank you for joining us today. It was great having you on. And I believe if there's any